Your laptop is wasting AI performance right now. Not because it is too old, not because you forgot to buy a $4,000 GPU, and not because local AI is only for people with a glowing workstation under the desk. The real problem is that most people run local AI like they are trying to prove a point. They download the biggest model they can find, they crank the context window, they leave every app open, they wonder why the fan turns into a jet engine, then they decide local AI is slow. But that is the wrong conclusion because the people getting impressive results on small machines are not winning by having magic hardware. They are winning by being ruthless. They pick smaller models, they quantize properly, they manage memory, they use context like it costs money even when it does not. They route simple jobs to tiny models, they only wake up the monster model when the work actually deserves it. And that is the whole secret. Local AI is not about running the largest model your machine can technically survive. It is about making your machine feel fast, useful, private, and cheap enough that you actually use it every day. That means the best local AI setup for most people is not the most impressive one on paper. It is the one that stops wasting the machine you already own. Hey, don't forget to like and subscribe for more like this. Now, back to the video. The first mistake is treating model size like a scoreboard. Someone sees a 70 billion parameter model, then a 120 billion parameter model, then a 480 billion parameter model. And suddenly a 7 billion model feels like a toy. That is nonsense. Model size matters, of course it matters, but local AI is not a benchmark trophy cabinet. It is a workflow. If a model gives you a better answer but takes so long that you stop asking questions, it has failed. If a model can reason well but eats so much memory that your editor crawls, it has failed. If a model technically runs but every response arrives like wet concrete, it has failed. The local model that wins is the model you can keep in your flow for code explanation, quick summaries, commit message drafts, search queries, shell command suggestions, data cleanup, and simple refactors. A small model can be shockingly good, not frontier model good, not replace every cloud subscription good, but useful, instant, private, and free per prompt good. That matters because the real magic of local AI is not that your computer becomes a data center. The magic is that AI becomes cheap enough to use casually. You can ask the dumb question, you can paste the private log, you can summarize the boring file, you can generate 5 throwaway options, you can do it without thinking about credits, rate limits, or whether the prompt should leave your machine. But that only happens if the model feels responsive. And responsiveness is mostly a memory problem. Most people ask the wrong hardware question. They ask, how fast is my CPU? Or do I have a good GPU? The better question is simpler. Can the model fit where it needs to fit? A model is a huge pile of numbers. Those numbers have to live in memory while the model runs. On a gaming PC, that usually means GPU memory first and system memory second. On Apple Silicon, the CPU and GPU share one pool of unified memory. That difference is massive. A Windows desktop with a fast graphics card might have a powerful GPU and only 12 gigabytes of VRAM. That is great for games. It is less great when the model, the context, and the cache all want to live inside that same 12 gigabytes. An Apple laptop with 32 gigabytes of unified memory may look less dramatic on a spec sheet, but local AI can use that shared memory pool in a very practical way. That does not make the Mac automatically faster. It means it is often easier to run larger local models without hitting a hard VRAM wall. This is why local AI advice gets so confusing. The machine with the stronger GPU is not always the machine that feels better for a big model, and the machine with less flashy graphics can sometimes run a model that technically should feel out of reach. The rule is this: if the whole model fits in fast memory, life is good. If part of the model spills into slower memory, life gets slower. If the model fits only by crushing the rest of your system, life is pain. So the goal is not to barely load the model, the goal is to load it with room to breathe. Quantization is the reason local AI works on normal computers. Instead of storing model weights at a large precision, you store them with fewer bits. That cuts memory use dramatically. It can also make models faster. This is how a model that would otherwise be absurdly large becomes something you can run from llama, LM Studio, or llama.cpp. But quantization is not magic. Go too low and the model starts losing sharpness. It may follow instructions worse. It may make weirder mistakes. It may become worse at code. It may sound confident, while quietly being less reliable. The trap is thinking the smallest file is always the smartest choice. It is not. For most normal local AI use, 4-bit and 5-bit quantizations are the practical middle ground. 8-bit can be great if you have the memory. Tiny 2-bit versions are interesting, but I would treat them like survival mode. They are useful when the alternative is not running the model at all. They are usually not where I would start if I wanted a good daily assistant. My opinion is simple. Do not chase the largest model at the ugliest quant. Run a smaller model at a healthier quant. That sounds less impressive until you actually use it. A clean 12 billion model can feel better than a wounded 30 billion model. A fast 7 billion coder can beat a huge model that makes you wait so long you stop iterating. Local AI rewards balance. The best setup is rarely maximum size. It is the highest quality model that still feels alive on your machine. The next mistake is turning the context window into a storage unit. Modern local models advertise enormous context numbers. Gemma 3 has versions listed with a 128,000 token context window. Qwen 3 Coder advertises long context for repository scale work. Some models talk about 256,000 tokens or even more. That sounds incredible. And it is incredible, but long context is not free. The model does not just remember things because the number is printed on the page. The system has to process the prompt. It has to maintain a cache. It has to move data through memory. The bigger the context, the more your machine has to carry. So if you set a huge context window because it sounds powerful, then paste in an entire repo, you may have just turned a fast local assistant into a sleepy one. This is especially painful on small machines. The same model can feel snappy at 8,000 tokens and miserable at 64,000. The answer is not to avoid long context. The answer is to earn it. Use small context for normal chat, use medium context for file level work, use giant context only when the task really needs it, and for code, stop dumping everything into the model. Give it the relevant file, give it the error, give it the function, give it the test output, make the prompt smaller, and the model suddenly gets smarter because it is spending less effort carrying junk. This is the most underused local AI performance trick. The cheapest token is the one you never send. Here's where things get interesting. Small models are not just budget models anymore. They are becoming specialized tools. Gemma 3 includes tiny sizes like 270 million and 1 billion parameters, and larger local friendly sizes like 412 and 27 billion. Qwen 3 Coder has a 30 billion parameter version with only a fraction of the parameters active at once, which is exactly the kind of efficiency trick that makes local coding models more interesting. OpenAI released GPT-OSS 20 billion and GPT-OSS 120 billion as open-weight reasoning models, with the smaller one designed to run on consumer-style hardware with around 16 gigabytes of memory. That sentence would have sounded ridiculous not long ago. An OpenAI open-weight reasoning model on a personal machine. That is the kind of thing local AI people used to hope would eventually happen. Now the question is not whether you can run something impressive. The question is whether you are smart enough to use the impressive things selectively. Because a 20 billion reasoning model should not answer every throwaway prompt. That is like using a database migration tool to rename a folder. You want a tiered setup, tiny model for quick classification, rewriting, summaries, and simple commands. Medium model for regular coding help. Reasoning model for hard debugging, planning, architecture, and tasks where being wrong is expensive. This is how you make a small machine feel larger than it is. You do not ask one model to be everything. You build a local bench, fast model, careful model, coder model, vision model, if your machine can handle it. Then you pick the tool based on the job. That sounds obvious, but most people do not do it. They install one model, judge all of local AI through that one model, and leave performance on the table. Let us talk about GPUs, because this is where a lot of people waste money. If you are buying hardware specifically for local AI, VRAM matters more than almost everything else. A faster card with less VRAM can lose to a slower card with more VRAM for larger models. That feels wrong if you come from gaming. But language models are hungry in a different way. Frames per second does not tell you how happy a model will be. Memory bandwidth matters, VRAM capacity matters, software support matters. NVIDIA is still the easiest recommendation for many Windows and Linux users because CUDA support is so strong across AI tools. But that does not mean every NVIDIA card is a local AI monster. An 8GB card is useful, but it is not magical. A 12GB card can do a lot, but you will still make compromises. 16GB starts to feel much more comfortable. 24GB is where serious local AI becomes much more enjoyable, and 32GB or more is where you start breathing differently. But here's the uncomfortable part. If you already own a machine, the smartest move is often not buying a new GPU, it is learning what your current machine can run well. A small model that stays fully accelerated is usually better than a huge model split awkwardly between GPU and CPU. Local AI gets ugly when your setup is technically possible, but emotionally annoying. Every token feels like waiting for a website to load in 2007. Do not build that machine. Build the one you will actually use. Apple's silicon deserves its own section because it changes the trade-off. On many PCs, the GPU and CPU have separate memory. On Apple silicon, there is unified memory. The CPU and GPU can access the same memory pool that makes Macs surprisingly good for local AI, especially if you bought enough memory. A MacBook with 16 gigabytes is not a miracle box, but it can run useful local models. 32 gigabytes is much more comfortable. 64 gigabytes and above can get genuinely interesting. The thing I like about Apple Silicon for local AI is not that it always wins benchmarks, it is that the experience can be clean. You install the tool, you pick a sensible model. Metal acceleration works. The machine stays relatively quiet. The memory pool gives you flexibility. For developers who want private local assistance without building a hardware project, that matters. The mistake is expecting a MacBook to behave like a rack of GPUs. It would not. But if your goal is useful, local coding help, private document work, light agents, and fast iteration with smaller models, a well-spec'd Mac can be excellent. Again, the answer is not maximum model size. The answer is matching the model to the machine. Now, for the most underrated setup, CPU-only local AI, people talk about it like it is a punishment. It is not. It is slower, obviously, but it can be useful. llama.cpp exists partly because running models efficiently on ordinary hardware matters. It supports CPU builds, GPU backends, hybrid CPU and GPU inference, and formats like gguf that made local model distribution much more practical. If you have a modern CPU and enough RAM, small models can be perfectly usable, not glamorous, not instant, but usable. And CPU only can have one huge advantage. System RAM is often cheaper and larger than GPU RAM. That means you may be able to load models that your GPU cannot hold as long as you accept lower speed. This is great for overnight processing, private summarization, batch work, and tasks where latency is not the main thing. The trick is to stop pretending CPU only should feel like a cloud chatbot. Use it for the jobs it is good at: longer background tasks, bulk text cleanup, private documents, indexing, drafting, offline work. If you need instant code completion, CPU only will probably frustrate you. If you need a private local worker that can grind through text while you do something else, it can be surprisingly valuable. If I were setting up local AI for a normal developer today, I would not start with the biggest model. I would start with the boring layer. Llama or LM Studio for easy model management. llama.cpp underneath the world for the serious efficiency work. A few gguf models at different sizes, a local API endpoint so editors and small scripts can talk to the model, then I would build 3 lanes. Lane 1 is fast. This is the model you use for quick answers, transformations, titles, summaries, and throwaway drafts. It should feel almost instant. If it does not feel almost instant, it is too large for this lane. Lane 2 is useful. This is your daily coding and reasoning model. It can be slower, but it should still feel conversational. This is where models like Gemma 312 billion, Quencoder variants, or GPT-OSS 20 billion become interesting depending on your machine. Lane 3 is heavy. This is the model you use when you're willing to wait. Big context, hard debugging, architecture questions, complex private documents. The important part is that lane 3 is not your default. The heavy model is a specialist. If you make it the default, you will quietly train yourself to use local AI less. That is the opposite of the goal. The best local AI setup makes small questions frictionless and big questions possible. Most people only optimize for the second half. That is why their setup feels impressive once and annoying forever. Your local model is competing with everything else on your computer: browser tabs, Docker containers, Electron apps, game launchers, screen recorders, indexers, dev servers. Every one of them wants memory. Every one of them can push the model closer to spilling, swapping, or slowing down. This is where local AI starts to feel less like AI research and more like being honest about your desktop. If you want better local AI performance, close the nonsense. Unload models you're not using. Use model time to live settings when the tool supports it. LM Studio lets you set a time to live so an idle model can unload after a period of inactivity. That is exactly the kind of boring setting that makes a local workflow nicer. Do not leave 3 huge models sitting in memory because you might use one later. Do not run a local model, a giant browser session, a video editor, a dev database, and a game update, then blame the model for being slow. Your machine has a budget. Spend it deliberately. The wild part is that local AI can feel dramatically better without changing the model at all. Same computer, same model, cleaner memory, smaller context, better offload, fewer background processes. Suddenly, it feels like you upgraded. The weakest local AI setup is just a chat window. Chat is useful, but local AI becomes much more powerful when it is attached to workflow. You want scripts that call the local API. You want your editor connected. You want a model that can summarize logs. You want a command that explains a stack trace. You want a local assistant that can rewrite a commit message without touching the internet. You want repeatable prompts for the boring things you do constantly. That is where efficiency really appears. Not in a benchmark chart in the number of tiny decisions you no longer have to spend energy on. And this is why small models matter so much. A tiny model connected to 5 useful workflows can beat a huge model trapped in a chat app because a tiny model is present where the work happens. It is not waiting for you to remember to open it. It is part of the machine. That is the future I find genuinely exciting. Not one giant local chatbot, a local layer of small, cheap intelligence spread across your computer. If you want a practical checklist, here's the one I would care about. First, pick the smallest model that does the job well. That one rule solves more problems than almost anything else. Second, use the same quantization. Do not ruin a good model just to squeeze it into a machine that will hate running it. Third, keep context low by default. Increase it only when the task needs it. Fourth, offload to the GPU when it helps, but do not assume maximum offload is always the best experience on every setup. Use the estimator in tools like LM Studio when available. Fifth, unload idle models. Memory sitting under a model you're not using is memory your system cannot use for the work in front of you. Sixth, separate fast tasks from hard tasks. One local model should not answer everything. Seventh, measure tokens per second, but do not worship it. Speed matters, but a fast model that gives bad answers is just a very efficient way to waste your time. What you want is useful latency. Fast enough that you keep asking, good enough that you trust it for the task, small enough that your machine stays pleasant. That is the real target. So what can a small machine actually do? A lot more than people think. A modest laptop can run small chat models for summarization, rewriting, brainstorming, basic code help, and offline private prompts. A 16 GB machine can start touching surprisingly capable models if you choose carefully and accept limits. A 32 GB machine opens up much more comfortable daily local AI. A 64 GB machine, especially with unified memory or a strong GPU setup, can become a serious local workstation. But the most important upgrade is mental. Stop asking what is the biggest thing I can run. Ask, what is the smallest thing that feels excellent? That question changes everything. It makes you choose better models. It makes you respect context. It makes you stop wasting memory. It makes you build workflows instead of demos. And it makes local AI feel less like a stunt because a stunt is running a giant model once and posting a screenshot. A useful setup is asking a local model 50 tiny questions a day and barely noticing the machine is doing it. That is the win. Not the biggest model, not the longest context, not the fanciest benchmark. The win is when your computer quietly becomes more capable. If you're buying a machine for local AI, here's my opinionated version. Do not cheap out on memory. Memory is the thing you will hit first. For a laptop, 16 GB is the floor, not the dream. 32 GB is the sensible target. 64 GB is where local AI starts to feel much less cramped. For a desktop GPU, think about VRAM before you think about the marketing name. 8 GB is entry level, 12 is workable, 16 is better, 24 is the level where a lot of local AI starts becoming genuinely comfortable. If you're choosing between a slightly faster GPU with less VRAM and a slightly slower one with more VRAM, I would usually take the memory for local AI. If you're on Apple Silicon, buy as much unified memory as you can justify upfront because you're not upgrading it later. And if you already have a machine, do not assume it is useless. Install a sensible tool, try a small model, measure how it feels, then move up one size at a time. That path teaches you more than immediately downloading the biggest model with the loudest comment section. Local AI is finally crossing an important line. It is no longer just a hobbyist flex, it is becoming a practical layer for developers. Not for every task, not as a total replacement for frontier cloud models, but as a fast, private tool that handles more than people expect. The mistake is wanting local AI to be one dramatic thing. One giant model, one perfect setup, one answer to cloud AI. That is not how it gets useful. It gets useful through boring discipline, smaller models, better memory choices, cleaner context, separate lanes, local API-S workflow integration. The funny thing is that this makes local AI more impressive, not less, because anyone can torture a machine into loading a model it can barely handle. The skill is making a small machine feel powerful. That is where local AI becomes real. Your laptop does not need to be a data center. It needs to be good enough, fast enough, private enough, and close enough to your actual work that you use it without thinking. That is the future worth caring about. Not local AI as a party trick. Local AI as the quiet engine inside your machine. And if you set it up that way, a small computer can feel much more capable than its spec sheet has any right to suggest.